Out there in the silent, unending darkness, a fire burns. It is not the brilliant, youthful blaze of our own sun. It is something older, something stranger, a single point of light glowing with the crimson embers of a forgotten age. This star has witnessed the birth of galaxies. It has watched as nebulae swirled into existence and then faded into cosmic dust. It carries secrets from a time before time, a history written in light and gravity that we are only just beginning to read. And what it tells us is that the universe we think we know is far from the whole story. It challenges our most fundamental beliefs about creation itself. Imagine staring into the deep blackness of space. You are looking back in time. The light from the farthest stars has traveled for billions of years to reach your eyes. But what if one of those stars sent its light before the universe, as we measure it, even began? It sounds impossible, a paradox. There is a star in our own cosmic neighborhood, relatively speaking. It is catalogued as HD 140283, but astronomers have given it a more fitting name, the Methuselah star. Like its biblical namesake, it has lived an exceptionally long life. So long, in fact, that it seems to break the rules of reality. Our best measurements tell us the universe is approximately 13.8 billion years old. This is the cornerstone of modern cosmology. Yet, the Methuselah star appears to be around 14.5 billion years old. A celestial object that is seemingly older than existence itself. This is the paradox that has stumped astrophysicists for years. Initial estimates of its age were even higher, placing it closer to 16 billion years old. What makes Methuselah so unique is not just its incredible age, but its composition. It is a metal-poor star, meaning it is made almost entirely of hydrogen and helium, the raw ingredients forged in the Big Bang. Deep within the cosmos lies an object of incredible density. It is the crushed remnant of a once mighty star, a white dwarf. But this is no ordinary stellar corpse. This object, known as ZTFJ 1901+1458, is pushing the very limits of physics. It is a star squeezed into a sphere only slightly larger than our moon, yet it contains a mass roughly 1.35 times that of our entire sun. Imagine the sheer gravitational force of such an object. A single teaspoon of its material would weigh as much as an elephant here on Earth. It is the densest white dwarf ever discovered. This object is the product of a violent and dramatic past. Astronomers believe it was born from the merger of two smaller white dwarfs. This ultra-dense remnant is also spinning at an incredible rate, completing a full rotation every 7 minutes. Its magnetic field is 1 billion times stronger than Earth's. What makes ZTFJ 1901+1458 so strange is how close it is to a fundamental cosmic limit known as the Chandrasekhar limit. The story of ZTFJ 1901+1458 is not over. It is a story paused at its most dramatic moment. This incredibly dense white dwarf is on a path toward an even more bizarre transformation. If it had been just a fraction more massive, it would have crossed the Chandrasekhar limit. The star would have collapsed under its own immense gravity, triggering a runaway thermonuclear explosion known as a Type Ia supernova. But it did not explode. Instead, it sits just below that critical threshold, a ticking time bomb that failed to detonate. Its immense gravity continues to squeeze its core. The electrons, crushed together, are forced to combine with protons, creating a sea of neutrons. It is on the verge of becoming something else entirely, a neutron star, a body so dense that a sugar cube-sized piece would weigh as much as all of humanity combined. This object provides a rare look at a fascinating cosmic crossroads. It shows us that not all massive white dwarf mergers lead to spectacular supernovae. They may undergo what is known as an accretion-induced collapse. Instead of blowing themselves to smithereens, they quietly shrink into one of the universe's most exotic objects. A tiny difference in mass, a whisper of change, separates a star's complete annihilation from its transformation into a city-sized sphere of pure neutrons. In the grand cosmic cycle of life and death, a star's demise is usually final. When a white dwarf explodes as a Type Ia supernova, it should be completely obliterated, scattering its elements across space. But the universe, it seems, has a flair for the dramatic. Astronomers have discovered something that should not be possible, a star that has survived its own self-destruction. These are the zombie stars. One such star, known as LP 4365, is a fragment of a white dwarf that was part of a binary system. Its companions stole mass from it until it reached the brink of collapse and exploded, but the explosion was incomplete. It was a partial supernova, a failed detonation that did not have enough power to fully unbind the star. This zombie star is now hurtling through our galaxy at nearly 2 million miles per hour, a piece of stellar shrapnel from an explosion that it should not have survived. The existence of these zombie stars forces us to rethink the physics of supernovae. For decades, the type Ia supernova was considered a standard candle, but these survivors suggest that there is a spectrum of explosions. Some are weaker, stranger, and less complete than we thought. It means our cosmic measuring stick might not be as reliable as we believed, introducing new uncertainties into our maps of the universe. The universe is full of partners. More than half of all stars exist in binary or multiple star systems, locked in an intricate gravitational dance. For the most part, these systems follow predictable orbits, obeying the laws laid down by Newton and Einstein. But sometimes we find pairs that seem to defy all logic. Stars locked in orbits that should be impossible. Consider the case of the Cannonball, a pulsar, a rapidly spinning neutron star, and its white dwarf companion. The pulsar is incredibly massive, packing twice the mass of our Sun into a sphere the size of a city. This system is the most massive neutron star pair known, and it pushes the limits of general relativity. It is a cosmic gyroscope spinning in the fabric of space-time. Then there are the systems where stars are so close they are practically touching. These are the contact binaries, where two stars share a common outer atmosphere. In some cases, we find what is known as the binary paradox, where the less massive star in the pair has evolved to become a red giant, while its more massive companion is still in its prime. The only explanation is a history of dramatic mass transfer, where one star has fed off the other. For centuries, we have been mapping the heavens. From ancient star charts to the sophisticated models of modern astrophysics, we have strived to create a coherent picture of the universe. We have built what we call the Standard Model of Cosmology, a framework that explains everything from the Big Bang to the formation of galaxies. It is a monumental achievement of human intellect. But the strange stars we are discovering, the ancient Methuselah, the impossibly dense white dwarfs, the zombie survivors, are like uncharted islands appearing on our maps. They suggest that our understanding is, at best, incomplete. These anomalies are not just minor details to be ironed out. They poke holes in our most cherished theories. Each of these strange stars acts as a stress test for our models. Perhaps the problem lies in our understanding of the very early universe. The first stars, known as population 3 stars, were theoretical giants. Our models of gravity and particle physics cannot fully explain dark matter or dark energy, which together make up 95% of the universe. Is it possible that these strange stars are hinting at new physics? They are beckoning us toward a new, more complete map of reality. We began with a single, impossible fire burning in the dark. An ancient star that whispered of a time before time. From there, our journey has taken us to the crushing heart of a dying star, to the graveyards of stellar explosions, and into the impossible dance of binary systems. Each of these cosmic curiosities tells the same story. The universe is not only stranger than we imagine, it is stranger than we can imagine. These strange stars are not flaws in the cosmic design. They are features. They remind us that for all our incredible progress, we remain students of the cosmos, not its masters. We are explorers on the shore of a vast cosmic ocean, and the strange shells we find washed up on the beach hint at the unfathomable depths that still lie beyond our reach. The Methuselah star, the zombie star, the star on the brink of collapse, they are messages in a bottle, sent from the far edges of our understanding. The quest to understand these objects is more than just an academic exercise. It is the same drive that led our ancestors to look up at the night sky and connect the dots into constellations. Today, our tools are more powerful. Our telescopes can see farther, our computers can calculate faster. But the core question remains the same. What is our place in this grand, mysterious cosmos? The universe does not give up its secrets easily, but it does give us clues. It leaves us these beautiful, baffling, and brilliant puzzles to solve. The story of the stars is our story. It is the story of where we came from and where we are going. And as these strange stellar messengers continue to send us their light from across the void, We will continue to watch, to listen, and to wonder, forever humbled by the boundless strangeness of it all.